Before we do get into it, Sean, will you pray for us?
Thank you for today. Thank you that we get to come here and learn about word, and pray that we get to know this. Is just the words to say.
Amen. Well, in review, remember what we've gone over. God is the creator of everything, and in the first couple verses of Genesis, we see God creating both, or all three, time, space, and matter, right? In the beginning, God created the heavens and the earth. So the beginning is time, heaven and the earth is matter, and the earth was without form and void, and darkness was upon the face of the deep. So in that verse, we have those three key elements. For the creationist belief, if you believe that God intervened in creating, not every creationist or every Christian, even to be more specific, is going to say that God did it in 6 literal days. But we made the case for a young earth. We made the case for the young earth creationist view. But now we're dealing more with the concepts of evolution versus a young earth model. So the evolutionist claim actually has to rely on a whole lot of presuppositions that come before that. Primarily, they're naturalist materialists. So the only thing that matters to them is what they can find in nature. That everything has a natural explanation. There's something scientifically concrete. You can observe it, you can reproduce it, and you can measure it. And so that's how you know that you can believe in that thing. We're relying on our senses and our ability to measure and reproduce an observation. Now, the issue with that is they say, well, there's nothing immaterial. There's nothing supernatural, and so we can't fall back on a supernatural explanation. So if we can't say, look at all of this incredible design, God must have been an incredible designer, instead they come along and say, well, there is an appearance of design, but that's the result of natural processes over a really long time. And with enough time, random chance could bring about all the complexity that we see today. But it's really just relying on the amount of time that passes and the random selection to bring about these complex systems. We worked on the evidence that we see in nature of the view of competing origins. Where did matter come from? From a evolutionist perspective, they say it came from the Big Bang. The Big Bang created matter through some kind of a surge in energy that happened in a vacuum, and due to string theory, a particle popped into existence in the vacuum, and that particle, mixing with the energy at the right moment, exploded into all the matter that we have today. Does that sound like a miracle? Because even evolutionary theorists admit that they're asking you to believe in a miracle. They're asking you to believe in one miracle and not as many, but as we go through, they might not admit that the later mechanisms that they're relying on are also miracles, but we're going to see today that the creation of life, and later on we'll see that the production of the multiplicity of species that we see today is also further miracles down the line. So they'll say, well, we're only asking you to believe one miracle, but the Christians are asking you to believe in hundreds of miracles. The truth is, they're asking you to believe in just as many, if not more, miracles than the Christian worldview. They just don't want to call it what it is. They won't call a spade a spade. They want to come up with some other way that these things came about without God. So, in the cosmic origin debate, we looked at all of matter and where it came from. The really big question, the problem for the evolutionists, okay, if I grant you that the Big Bang happened, we'll take that on faith and just believe it blindly. Why do we see ordered planets? Why do we see star systems? Why do we see the Earth orbiting around the sun in the way it does that protects it from all the space junk from destroying the Earth and provides it with the energy and the heat from the sun that Earth needs to have life? And why is Earth in the right spot to have all of the necessary climate conditions required for life? Why can life exist here? Not only why can life exist here, but why do we even have stars and planets in the first place? Let's get away from the whole origin of life debate for a minute. Why do planets orbit around stars, and why do stars have fire within them that creates all of this radioactive material that it shoots out into space? How can we see this kind of complexity and order just in the existence of planetary bodies? Well, from an evolutionary perspective, if you have a big bang, you create this incredible amount of chaos. An explosion, you drill a hole in a rock, you put a stick of dynamite inside and you light that. What's going to happen to the rock? Will it turn into a castle? That rock is going to explode and pieces of rock are going to fly everywhere. You're going to have clouds of dust and broken pieces of rock, but it's not going to form into another bigger rock, and it's not going to somehow be formed into complex rocks. Instead, it's going to lead to more chaos. So you could think about it this way. Have you ever played solitaire? You sit down, and as an intelligent mind, you start laying out cards and organizing them by color and suit, right? And you go through and you organize the cards. Well, through the use of ordered processes and an intelligent mind, you can come up with something that is ordered and complex. Now, have you ever played 52-card pickup? It's a wonderful prank that we'd like to play on each other in middle school where you say, hey, let's play this new game. And the other kid's like, what game? And then you shoot 52 cards in their face, throw them in the air, what have you. And what happens? Do they organize themselves by color and suit? No, when you have random energy introduced into an isolated environment, it turns into chaos. And the cards end up all over the floor and mixed up in a big mess. That's what we should expect our planets and stars to do. We shouldn't expect them to have these ordered bodies of stars and planets and the solar systems that we have. But instead, we see order and complexity. There is not enough gravity to suck enough gas in to create a star from a cloud that comes from an explosion. Gravity is not the mechanism that can form a star. There is no evolutionary mechanism within the entire realm of physics to create a star. But what we see when we look out into nature is these incredible masterpieces of God. Now, when we go and we look at those stars, part of the evidence that we have that they just haven't always been there, we all have to agree that stars come from somewhere, is because all the stars are traveling away from each other. So, either God created the stars and then stretched out the heavens like the scripture says, or, well, hello guys, welcome to the class.
Hi. I'll be right back.
Oh, you're good. So as these stars are being formed and brought together, they are forming more complex bodies, and I forget where I was going with that. Oh, expanding universe. Yes, everyone agrees on creationism and evolutionism in the whole debate that there is an origin. We say God created and stretched it out. The evolutionists say, well, it all came from a single microscopic point that exploded. Well, the physicists can't make that one work. But the creationist view that God created it and it was good fits perfectly with the text of Scripture. And it fits perfectly with the physics that we see in the world today. Now, that the evolutionists will try and do a gotcha. They'll say, okay, well, if you say matter had to be created, I can have the same problem for you. Who created God? And that is a fundamental misunderstanding of definitions. If they say, well, who created God? It really is falling back into this more complex conversation about contingencies. If you look at a star and you say that the star formed through natural processes, you have to prove how that happened. They call it the burden of proof. You have the burden of proving how that star formed through natural processes. But if we say, hey, God created this and made it happen, well, who made God? You're assuming that God is something that had to be formed. You say that stars were formed and you can't explain how. I say God was not formed, and so I don't need to explain how God was formed. That is logically incoherent. You're asking me to do something impossible because God is eternal. So as God, he is self-existent, he has always existed, and he is perfect in his existence. So for me to say that somehow that is not a sufficient explanation of origins, you would have to come up with a more plausible, a better explanation that answers more of the questions. But the evolutionist perspective introduces more questions than it actually tries to solve. So again, we're trying to come at this from a naturalist perspective, but the evolutionists are asking you to believe in more miracles than what the creationist is asking for. Now we're looking at things. We just discussed some of these, the fine-tuning and the design. And from what Scripture says, we have a very clear portrayal of creation being purposeful, ordered. We see God making things and saying it is good. And when we read Scripture, we have this belief that if we go out into creation, because it was created by an ordered and consistent God, then we can expect creation to be ordered and consistent. So it is not a coincidence that it is the Christian philosophers, the Christian scientists, who are the ones who came up with things like the laws of thermodynamics. Those natural laws were discovered by men who believed in a God who created a world that makes sense. So the scientific advancement being paired with the rise of Christianity should not surprise any of us. Now, as we're moving forward in this conversation, we're coming to where did the foundation of life come from? So we kind of picked apart the evolutionist explanation of origins. If you have a logically consistent evolutionist, he is going to admit that, well, we don't actually know that we don't actually have mechanisms for star formation, but we'll figure that out eventually. And so they just kick the can down the road and say someone else will figure it out who's really smart. Down the road, someone will come up with a theory that answers these questions. And they try to make that their solution. Well, they are just kicking the can down the road and making a faith claim. Their faith is in the ability of the human mind to come up with answers for questions that they can't solve. But for a logical debate, you have to be able to work with things that are more concrete than that. You actually have to be able to prove something, but they can't prove that. But then, if we grant, okay, well, maybe the Big Bang did create all the stars and planets that we have. What is the natural mechanism? What is the natural law that caused rocks and acid and electricity to come together to form life? Where did we get our first piece of DNA? Or they say, well, maybe it came from the RNA world. That's a fun term they like to play with. Where did this RNA world, DNA came from RNA, so where did RNA come from? Oh, well, RNA came from this really cool interaction of amino acids, got hit by a burst of energy, and boom, you have protein synthesis, and you have these really neat peptide bonds where the proteins stick together. Okay, but while they were able to create peptide bonds in a lab, that doesn't mean they're necessarily useful. So these problems that face the evolutionists are what is going to be the next piece of our conversation. So we're doing another excursus. I'm sorry, I don't have notes for this one, so that's why I didn't have a handout today. But this one is our excursus into proteins and DNA. This is why we can't have nice things from an evolutionary perspective, right? So now let's look at this. This is a AI representation of what a protein fold looks like. And then see this little string and these down here? That's like zooming in on what the amino acids and the peptide bonds look like. So this is a very complex system. Proteins are complex chains of amino acids that are linked by peptide bonds that make up life's machinery. So if you're looking at this picture, you can see, let me pull up my laser pointer. You can see these little connections between the proteins. Those are called peptide bonds. And as we look at those peptide bonds that fuse the amino acids together, this is going to be helpful for understanding the building blocks for life. We'll make it a little bit simpler. Let's talk about bodybuilding. You go to the gym, you work out, you do a bunch of sets, you lift heavy weights, and then what do you need to rebuild your muscles? You go home and you eat protein. We're eating eggs, we're drinking whey protein shakes, we're trying to get protein in our body because our body needs those proteins. Now, how do you get protein? Well, you have to have enough amino acids. If all you're doing is eating vegetables, it's more challenging to get amino acids. But you can get enough amino acids to make a protein if you, using your intelligent mind, combine beans and rice. There are enough amino acids of a good enough variety that your body can manufacture proteins from beans and rice. And so a lot of poor countries, people will eat these diets of beans and rice, and that gives them the protein to grow big and strong and be built up in that way. Well, that's what's necessary for bodybuilding, but on a much simpler level, a single-celled organism like an amoeba is going to need the same thing. They're going to need these amino acids that chain together to form proteins. Now, we have to go back to the Darwinian primordial Earth, where we don't have a lot of carbon in the atmosphere. We have lots of volcanoes. We have really caustic acids. And so in that kind of an environment, where are we going to get these amino acids? Well, in the early 1900s, there were a couple of scientists who made some breakthrough studies and discovered how to synthesize peptide bonds. And when they discovered that, they said, oh man, we figured out the mechanism for the creation of life, and this is wonderful. We have these awesome answers for all the stupid Bible thumpers' objections. Well, let's actually look at what those discoveries were and see if that actually got us closer to hitting the target. The big target is synthesizing life. We're trying to create life in a laboratory to prove that it could have come about through random processes. The problem is that this is very impractical. Even in perfect lab conditions, these scientists who go and try and fuse the amino acids together are having a lot of problems. And even in a lab environment, they cannot even get close to producing a living single-celled creature. So evolutionary scientists are going to have to be able to prove this to be able to validate any kind of evolutionary process or evolutionary theory. So this brings us to the first problem, the first hurdle that the evolutionist researchers are encountering as they try to create life in a laboratory. First, they don't have the right kind of an atmosphere. In the 1950s experiment, this is a very famous experiment. It's called the Miller-Urey experiment, and it was done in 1953. And what they were able to do is create peptide bonds in a chemical process. The problem is, first of all, they had a reducing atmosphere. So this is where you have a very controlled system like they have in these Ambulex in this little lab setup here. You take out a lot of the oxygen because oxygen breaks down these peptide bonds, and you have methane, ammonia, and hydrogen in great supply. Now hold on, pause. Does our atmosphere have methane, ammonia, and hydrogen in our atmosphere? No. So the atmosphere that they used, the gas that was in the chamber to create these peptide bonds, is not something that we can observe in the world today. So already the naturalist process is falling apart. According to the evolutionists' theories, what we would see is neutral or mildly oxidizing atmosphere. We would have a lot of CO2, carbon dioxide, lots of nitrogen, and all of these gases would be very hostile to amino acid formation. So if we're trying to theorize how amino acids could form, trying to do it in Earth's atmosphere through random processes is actually not a great idea. So the scientists had to create a fake atmosphere that had a lot of methane, ammonia, and hydrogen. Now, under these idealized and incorrect assumptions, The experiment did not produce proteins, only some amino acids mixed with a toxic sludge of byproducts. Now, note that last line there, a toxic sludge of byproducts. When they were able to create peptide bonds, they were completely unusable. First of all, because as we'll see later for DNA, you can only have left-handed peptide bonds, and they had a 50-50 mix combined of left-handed and right-handed peptide bonds. But then all of the byproducts that came from this experiment created a toxic sludge. Additionally, they were using very pure selected chemicals in their solution. So if they're making this liquid that is from refined chemicals that you can only buy off of chemistry websites, well, how are you going to get this incredibly dense, pure mixture to create the peptide bonds in the first place? And then once you create the particles, it's so toxic in the sludge that the peptide bonds only last a couple of minutes, down to a handful of seconds. So these peptide bonds are not practical. There's no way for them to survive in the long term. Well, let's go on to the next problem. And this is the left-handed, right-handed. We'll go through it quick because it is kind of complicated. But essentially, those different amino acids can either be left-handed or right-handed. And when you just produce amino acids in a random solution, those amino acids are in a 50-50 ratio. But for life, you need exclusively left-handed peptide bonds. So these amino acids, they do exist in mirror image forms. All of life uses only left-handed amino acids. A chemical reaction produces a 50-50 mixture. And even one wrong-handed amino acid can destroy the entire protein fold. If the protein is not folded in the right shape, it doesn't produce a living cell. So that's a big problem. No known natural process can explain this homochirility. There's no way to explain why it's only left-handed amino acids. Well, let's go on to the folding problem. So you see again, there's our folded protein, right? And it has to be folded in the right shape to be able to produce DNA, to be able to produce life. And different kinds of proteins are used for different kinds of solutions. Now, we'll get into some of the really complex elements of a protein, but essentially the most important thing to remember is that these proteins have to be in the right shape, and if they're not in the right shape, then they don't work. You can't get a cell, so you can't get an organism, and so you can't get living complex beings. A modest protein has approximately 150 amino acids. Each amino acid can fit with another amino acid in different formations, and so if you take a moderate protein with 150 amino acids, that means that there are 10 to the 74th power possible configurations. Now remember, 10 to the 18th power is equal to all the sand on planet Earth. So 10 to the 74th power is orders of magnitude. It is just a mind-blowing number. I don't have any way to represent it. It is so impossible to randomly get the right amino acid bonds to form a protein. That doesn't happen by random chance. It has to happen through an intelligent mechanism. So only a few different versions of these folds is going to be able to work correctly. Now, if we try to map the protein folds, you can kind of see the chemical bonds that help illustrate what this looks like. But when people go and they research and they try to map these protein folds, this is actually a very productive side of science for people to get into. There's a lot of funding going towards origin of life research, and so people are really working quite hard to map these protein folds. The first protein fold that was ever mapped was mapped in 1972 by Christian and Finsen, and he was able to show that protein folds are mapped and that they are actually mapped according to a set of information within the proteins. Max Puretz and John Kendo are the first ones to map hemoglobin and myoglobin. and it took them an entire life's work to map one protein. That happened in 1962. Now, if we're going to try and map these proteins, this is evidence of an intelligence at work. Just mapping a protein is such a complex process to be able to say, hey, that's a protein and this is what it looks like. People have devoted their lives and millions upon millions of dollars of researching this. It requires X-ray crystallography. I don't even know what that is. It requires massive human effort. It requires advanced mathematics, advanced chemistry, and physics to be able to understand how all this works and fit it together. So we're talking, there are really, if there were over 100 experts in the world who really had mastered this concept, I would be surprised. It is an incredibly complex process, and people are winning these global recognition prizes, the Nobel Peace Prize, for their advancements in this process. For life, you don't just have to have observed and mapped what already existed. You have to have random processes, random chance, forming new proteins by pure chance, without any kind of intelligence or design. Now, life requires at least 250 correct proteins, which all have to be present together at the same time. So we have this primordial ooze that randomly gets hit by a bolt of lightning and a cell appears. Well, that makes no sense if you go and look at the science, because you have to have not just a few peptide bonds, but you have to have all left-handed peptide bonds that are all together with the correct peptides to form proteins, and then those proteins have to be shaped into the right shape, which is almost mathematically impossible to happen by random chance. And then to form life, you have to have 250 of those proteins all working together at the same time. Now, what is that? We're up to 5 miracles just for the formation of life, and we're about halfway through. We're not done. A typical cell can have 42 million proteins. So the most simple possible cell to live is 250, but the average cell, a common cell, has 42 million proteins. You see how ridiculous this is starting to sound, that it happened by natural chance. It doesn't happen that way. Let's keep working on this problem. To be able to map and understand proteins, there's this incredible thing that happened like back in 2022. I'm not sure if you guys have heard of it. It's called AI. And using AI, we have been able to make some incredible advancements in this world of mapping proteins. If you'd like to really nerd out and get into how AI is mapping proteins, I believe the science channel Veritasium gets into some of the advancements they've been making. Really an interesting video, but we didn't have time for a 45-minute video to watch in here today. But essentially, the AIs are able to harness all of the data sets, which a human mind can only hold one idea at a time. But with an AI, you can hold all of the data sets in memory simultaneously. So they can get these massive data sets and work through all the information at the same time. And using these neural networks, the supercomputers can come up with a theorized map of what a protein looks like. So over the course of the history of science, we had only mapped up to about 9 different proteins after dumping millions and millions of dollars into mapping protein. But now, with super intelligent AI, we have made some incredible advancements. There's an organization particularly, it's called AlphaFold, and they're working on the Deep Mind project, and they have been able to come up with a lot more proteins. As of a year ago, I think they had mapped 150 in this one program. And there are other programs in addition to it that are also working on mapping proteins. So we are making some really neat, really incredible advances, but this is with the use of intelligence. Now, how do we come up with all these proteins through random chance without any intervention and without any intervening intelligence? Do you understand why I say an evolutionist is asking you to accept a lot of miracles? You go and you watch the Discovery Channel, and they're not going to say, hey, for this theory to work, you have to have 16 miracles all in place at the same time for this to happen by random chance. They just say, random chance did it. It's really not possible. And they have no mechanism to explain why it is possible. So really, while they try and say that Bible-believing Christians are wrong and they're just superstitious, their explanation is actually a whole lot worse. And if you just understand a little bit of what's behind their false assumptions, it really disarms so many of their arguments. And you can look at it and say, yeah, but I have a rational mind and I can't simply accept that random chance created all of this. A rational explanation demands some kind of intelligent design. Now, as we move from the problem of amino acids to form a peptide bond, which has to be the right kind of peptide bond to form a protein, and then to have a properly functioning cell, your typical cell is going to need 42 million proteins, and the most simple cell possible still requires 250 proteins. So we're already several layers deep on the miracles here. Now we need to come up with some natural process that will go from a protein to form RNA. So I didn't have time to come up with a picture of RNA for you. So I've got DNA, but if you use your mind's eye, you can split that DNA in half and boom, you've got RNA. So RNA is ribonucleic acid, and it is 1/2 of a strand of DNA, and it's what the cell produces to be able to send out genetic information to pair with proteins and create a new strand of DNA. So random protein synthesis is impossible, but evolutionists say that random protein synthesis is what took the first step towards life, and then that protein, which is impossible to form by random chance, also randomly assembled into RNA. Now, RNA has 4 different pieces of information that's encoded on this strand, right? So they're often represented by the letters A, C, U, and G. That's often what you see as the different labels for these proteins. But the proteins have to spontaneously form into this specific chain of proteins that can exist for long enough to collect other proteins and randomly, miraculously form into DNA. Now, according to the evolutionary idea, this process took a really long time and random chance, and somehow, if you give it enough time and enough random iterations, eventually you will get a piece of RNA. Now, for RNA to form, it requires other mechanisms within a cell that is providing what it needs to exist. The really big problem with RNA is that if you're trying to apply time and random chance to allow RNA to form, RNA is chemically unstable. So we're talking about most RNA degrades, if it's not in a controlled environment, most RNA degrades within a couple of minutes. In a controlled environment, it might be able to last up to a day. So if we're gonna say random chance made this happen and then random chance changed a piece of RNA into a piece of DNA, how does that work if it can only last a couple of minutes? You have a time limit. There is a ticking stopwatch as soon as you create a piece of RNA. And according to the evolutionist theory of how DNA formed from RNA, the solution is just adding more time. But they just blew it. Because to form from RNA into DNA, you have like a 2-minute stopwatch. And as soon as you blow past that, it degrades and you don't have information anymore. You go back into random chaos. So how do we get an ordered system from the natural process? It simply cannot happen. There is no way to explain this. Now let's move to the next point, that RNA moving to DNA is a leap without a bridge. How do you go from one cliff to another? Well, you have to cross over something, but there is no mechanism to move you from RNA to DNA. To move between RNA and DNA, you have to have proper enzymes, which are complex mechanisms. You have to have ribosomes. You have to have translation systems, and you have to have repair mechanisms. Yes?
Sorry, maybe I missed this, but how did we create the RNA? Is this the random proteins that happen to all come together, and that's what created the RNA first? That
Yes.
to the DNA? Okay.
Yeah, so protein randomly formed together and magically formed RNA through no known process.
Okay.
And now we're magically going from RNA to DNA.
Okay.
And we run into a lot of the same problems as we have with trying to form RNA. Those systems are actually encoded into the DNA itself. This is kind of like a chicken or the egg problem. If the systems to create more DNA resides only in DNA, well then where did the first strand of DNA come from? You had to have DNA in the first place, right? So if we believe that God created the chicken, then it makes sense that the eggs would come later. If God created the DNA, then we do have things like RNA that come later. So from the evolutionary perspective, they end up with what's called circular dependency, where you have to have one to create the other, and to have the other, you have to have the original DNA. But they have no mechanism to actually get that DNA. The wonderful thing about DNA is that it is more stable. It is double-stranded, so it makes it a much stronger mechanism. It has in itself a code that is error correcting, and it can hold vast amounts of information that is greater than that of a piece of RNA. Now, when they talk about the amount of information that is encoded into a strand of DNA, are you guys familiar with the Encyclopedia Britannica? If we had the Encyclopedia Britannica, we could put bookshelves on that full wall, and it would probably fill up the entire wall with all the encyclopedia articles. The amount of information in DNA is about equivalent to the Encyclopedia Britannica. So we're talking about an incredible amount of information that's encoded in this massive library that is smaller than what you can see with the naked eye. With all the computing systems and ways to store information that we have today, we cannot get anywhere close to the ability that DNA has to encode information. We haven't come up with it. With the billions of dollars that are in the tech industry, we just can't even get close to matching what is in biological systems. So we have this circular dependency problem. But to look more at what DNA is, we can compare DNA to what we have as computer codes. So in a computer code, everything is encoded through binary, which is a series of ones and zeros, right? Well, DNA is a much more complex computer code. Instead of using two different ways to encode it with a 1 or a 0, instead, DNA has the A, C, U, and G, and using those, it can actually be much more compact than what we have in digital numbers. Now, if we're going to look at this incredibly complex code, and we compare it to human software, who would believe that the programming behind Facebook made itself? I mean, what video games have you guys played in the last month? Do you think that video game just happened by natural processes through random chance over enough time? The smart Alex says yes, but really no. There's no way for that to randomly happen by chance. Someone had to sit down with a programming team, and they came up with the Unreal 10 engine, and then other programmers came along and harnessed the Unreal Engine and programmed in different characters and rules and an environment that those rules work in. And then animators came along and gave those rules a realistic world that you can go and then experience all of that in. And then you can go and hear this wonderful story that was written by an intelligent mind. Computer code is orders of magnitude more simple than what we have in actual DNA. DNA is a code that will debug itself. It has a 3D dimension to it, where while it has an incredible amount of information, not all of that information is always accessible. So think about the last time you had the stomach flu. You felt really sick, and your body had to activate all kinds of systems with your immune system and producing more white blood cells to go and attack the virus that you had in your system. And something else that happened is your stomach started to produce different enzymes. To produce those enzymes to fight off the virus, DNA has to change in a three-dimensional shape to a different form to produce the proteins that go and fight whatever your disease is. So you have not just a three-dimensional information system, but it's actually a fourth dimension because it crosses over time. The cells that are in your gut and your liver and your pancreas, as you come across different needs in your environment, those reshape like a transformer robot so that it can perform different tasks and help you in different ways. So you have the incredible amount of information encoded, but then different pieces are available at different times to perform very specific tasks. This so far transcends any level of human information coding. It has these incredible built-in mechanisms that protect the system from outside threats and outside dangers. Now, as we continue moving on, we can see how this kind of complexity, we didn't move from DNA to the cell and from the cell to a multi-cell organism and from a multi-cell organism to complex life that we see in mammals and birds and fish. Those kinds of things are out there to be debated. But when it comes just to this DNA problem, DNA is not self-sufficient and cannot exist meaningfully in any kind of isolation. DNA does not catalyze its own reactions and cannot perform work on its own. It functions as an information repository, but is not in itself an active agent. And so DNA needs enzymes that will help insert and remove pieces of information. In addition to this, DNA requires pre-existing cellular structures. So, guys, what's the powerhouse of the cell? Mitochondria is the powerhouse of the cell, the one thing we learned from science. To be able to reproduce a strand of DNA, you have to have the powerhouse of the cell. You have to have mitochondria producing a substance in the body called ATP. ATP is the energy source for life. To be able to have a cell that functions and can move and can fight off viruses and can reproduce itself, you have to have ATP. So, if we're going to have this incredibly complex strand of DNA that exists within a cell that can reproduce itself, well, that cell is going to have ATP, and the ATP is going to have ribosomes, and as you get going down the line of what is required, a single cell is an irreducibly complex system. There's no one part that you can take out and say, well, this part formed before this part. That doesn't work with a single cell. One cell has to have all the systems in place at the same time to be able to function. The continuous energy supply, if you cut off ATP, the cell dies and the DNA degrades within a matter of minutes to hours. So the evolutionist saying, well, just add more time actually degrades the system and makes it more implausible. You keep adding time and random chance, and you're actually making it more and more impossible for this thing to exist. DNA requires a controlled chemical context. DNA requires a continuous energy supply. The energy has to be captured, converted, and regulated. So where do our cells get energy from? Well, it comes from the mitochondria, which relies on ATP. Well, where does the mitochondria get the glucose to turn into ATP? Well, you had to eat it first. Oh, well, what did you eat? Oh, well, you ate another living organism. Well, where did that living organism come from? They don't know. So what you have to have is you have to have a planet that is close enough to the sun to have liquid water, but far enough away from the sun that it doesn't burn to death. and then you have to have the liquid water that can provide the liquid for a plant to grow. The plant has to be there to be able to absorb light from the sun, and through photosynthesis, it produces fruit that you can eat, and then you eat the fruit, and the fruit turns into glucose through the complex systems of your body and your stomach, and then down the line through DNA.
So, how they say there was like a single cell organism that started this whole thing, right?
Right.
Just decided to create itself. Or whatever.
Spontaneously jumped into,
Okay.
yes.
So that had to have eaten something else, maybe
Right.
another one of itself, or,
Correct.
right? Because that doesn't make sense.
It would have to eat something to get energy.
Yeah.
Yeah.
So, I don't know. Okay.
They theorized that maybe part of what it ate was maybe some kind of a rust oxide. It might have consumed iron for some kind of energy.
Okay.
But that does not actually answer the problem, because you need more than iron for nutrients. You need more nutrition than just iron in a system. So that answers a very small slice of the puzzle, but it doesn't provide an energy system for the cell. Absorbing an iron oxide is not quite enough to fuel life as we know it. So then we see also that DNA can't be replicated without a cell. So this piece of DNA spontaneously is created, and then it tries to reproduce itself, but there's no nucleus in the cell for it to exist in, and there's no cell for it to exist in, so that falls apart. But then to be able to have cells that multiply, if we're going to move down the chain further, cell division requires integrated machinery. So over and over again, we see DNA that requires a cell already in existence. To have DNA at all, you have to have a cell. So you can't start with a minor part and say, well, that's where it all came from. It just continued growing and mutating and evolving to be more and more complex. There is a certain level of irreducible complexity. You take one block out of that entire system, and it all crumbles to pieces. If you try to produce a piece of DNA with a right-handed amino acid, guess what? You don't get anywhere. And so this is what's really happened. You have the Miller-Urey experiment that they did in, 1953, where they were able to produce these amino acid bonds. And they're like, hey, look, peptide bonds in a lab. We just found the answer to life. This is where it all came from. But then, a few years later, Watson and Crick discovered DNA. And a few years later, they discovered that proteins are three-dimensional objects. And a few years later, and as each of these discoveries were made, they didn't get closer to the center of the target. As they kept learning more and more about life and the building blocks required for life, this target of abiogenesis, creating life from nothing, gets further and further away. So really, where we are now, we understand so much more about the cell, and we understand how much more impossible it is than when Watson and Crick first discovered DNA, or when Miller and Urey first formed the peptide bonds in a lab. As we learn more, the evolutionist worldview becomes more and more unbelievable. So this leads us to the conclusion. Why is creation rational? Really, creation is rational because when you look at the complexity of life around us, it can't have come through natural processes. You had to have a powerful, intelligent mind that exists apart from the material world. He has to be greater and more intelligent than all of this. As we look around at the complexity of life, it couldn't have appeared accidentally. Life requires irreducible complexity in its environment to have proteins, DNA, and more for all the building blocks. And that as we go deeper and deeper with science, the natural processes and materialist explanations become less and less believable. So as men try to create new life in a laboratory, they discover more about the requirements for life, and these goalposts move further and further away. When it comes down to what we have in the observable world, we can look at history, and our history leads us straight back to the reliability of the Bible. When we look at the Bible gives us a very rational explanation for where life came from. In the beginning, God created the heavens and the earth was without form and void, and darkness was upon the face of the deep. and the Spirit of God moved upon the face of the waters. And God said, and he made everything. And it says when he made it, it was good. What we have when we come to the Bible is a very understandable, rational explanation for where everything came from. Without the Bible, all of our understanding of the meaning that we have in life, of our purpose in this world, of our origins and where we came from, it falls apart and we're left with nothing. We're left grasping at straws, and the scientists claim to have the answer to the problems, but really, when you try to answer those problems from a naturalistic perspective, it all simply falls apart. So, no amino acids in natural processes, no amino acids, no peptide bonds, no proteins, no RNA, no DNA, no cell, no DNA, no cell, no life. So that is really the chain that all along the way, there have been millions of dollars in bounties placed on solving these problems from the evolutionary perspective, and nobody has been able to answer a single one of those problems. And in fact, as we continue to study, there are more and more holes in their theory. But the more you study the Word of God, the more beautiful it becomes, the more you understand it, and the more of these questions it really does have a rational answer for. So with that, that brings us to the end of our excursus. There are no excuses, and according to an evolutionary worldview, we really can't have nice things. Mr. Eric, would you close us with prayer?